Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to start our journey with algebraic fractions. We're going to start by talking about equivalent fractions and then reduced fractions. And I just want to remind you or review numerical fractions at the same time we're doing algebraic fractions. So basically an algebraic fraction is a fraction where you have an algebraic expression in either or both the numerator and the denominator. And as with numerical fractions, you can multiply the numerator and the denominator by the same factor without changing the actual value of the fraction. You can also divide the numerator and the denominator by the same factor without changing the value of the fraction. So for example, if I looked at a numerical fraction, if I wanted to express this with 8 as the denominator, I want to know how many 8s this is, I could multiply the numerator. Well, to get 8 in the denominator, I need to multiply by 2. Whatever I multiply the denominator by, I must multiply the numerator by the same thing. So the equivalent fraction would be 2 8s. 2 8s and 1/4 are the same. I can do the same thing with an algebraic fraction. If I wanted to get a different denominator, as you'll see when we're adding and subtracting fractions, we need common denominators, and that's why I might want to do it with the numbers as well. So often you'll have to multiply your denominator by some factor to get the lowest common denominator. So whatever you multiply the denominator by, you have to multiply the numerator by the same thing. So maybe I wanted x squared as a denominator. That means I would multiply the numerator by x and the denominator by x. I could leave it in factored form, or I could expand it depending on what I was going to do next. One thing I want to point out is that when you start manipulating your fractions, in this case multiplying by a factor in both the numerator and the denominator, you can only multiply or divide the numerator and the denominator. You can't start adding things to the numerator and denominator. That doesn't work. You can't subtract something from the denominator and subtract the same thing from the numerator. That will not work. You can't, let's say, square the numerator and square the denominator, and you might think, well, I'm doing the same thing to the numerator and the denominator, but the only same thing that you can do is multiply by the same factor or divide by the same factor. So I see that as a common mistake, and I just wanted to point that out. And I'll probably mention it again and again. So let's take a look at reducing fractions or simplifying fractions. So when you're working with numerical fractions, sort of the general rule when working with either numerical or algebraic fractions is always to reduce to the lowest form. And that requires canceling out or dividing by common factors to the numerator and the denominator. So in this case, I could divide both 6 and 16 have a common factor of 2. So I could either write it as 2 times 3 divided by 2 times 8. And once you have it in factored form, we can cancel common factors. So I can cancel the 2 in the numerator and the denominator, and that gives me 3 8s. Or you could simply, if you looked at this and you wanted to say, well, 2 goes into there 3 times and cross it out, put a 3. 2 goes into there 8 times, cross it out, write an 8, and you're left with 3 8s. That would be fine as well, as long as you understand that what you're canceling is a common factor, so you're dividing by the same number. We can do the same thing with algebraic fractions, and something else comes into play with algebraic fractions, and that's a factor of -1. Another rule when you're reducing is you want to have the fewest numbered negatives as possible in your fraction. So in this case, I actually can do a little bit of manipulation to make this look a little bit cleaner, and it would be the new result would be the preferred one to this one. This has more negatives than it needs to have. Now I just can't cancel a negative because remember I said you can't cancel terms. You can only cancel factors. So this is a term in this numerator, so I can't cancel it. I can't cancel the negative because the negative is a factor of the a, which is a term in the numerator. What I am going to do, however, is that I'm going to factor out a -1 out of both the numerator and the denominator. So when I factor out a -1 out of the numerator, I'm going to be left with a minus b. If I were to distribute that negative, you'd see I'd get back to -a plus b. I'm going to factor the -1 out of the denominator. You don't really have to write that with the brackets if you don't want, but it's like I have a factor of -1 and -1 in the numerator and the denominator, and I'm going to cancel those common factors. So this would be equivalent to a minus b over a, and this would be preferred to this. Just looks a little cleaner. Fewer negatives, that's always your goal. You want the cleanest result that you can get. In our next example, again, what I often see students want to do is they want to cancel the x squared, but we know we can't do that because x squared is a term in the numerator. However, I could factor my numerator. I could factor an x out of both terms. X squared, I'm just going to write it as x times x. You don't have to. And now you can see that you have a common factor of x in the numerator and in the denominator. So my result will be x minus 3 divided by x. That would be considered simplified. So in order to simplify algebraic fractions, we have to know how to factor. Okay, in this next example, I have a trinomial in the numerator, I have a trinomial in the denominator, and we've learned how to factor trinomials, so we're going to go ahead and do that. In the numerator, I'm looking for two numbers that multiply to equal -10 and add to equal -3. Those two numbers would be -5 and +2. So my factors will be a minus 5 times a plus 2. I do the same thing with the denominator. It's a trinomial. The leading coefficient is a 1. So I'm looking for two numbers that multiply to equal 15, +15, and add to equal -8. And those two numbers will be -5 and -3. So that was for the numerator. That's for the denominator. I covered all of this in my video on factoring trinomials, the leading coefficient of 1. So if you're getting lost here, don't get frustrated. Go back and look at what the process was, because I'm not going to teach that process while we're moved on to a new concept. But go back and review that so that you don't get lost when I'm actually doing the factoring. So that's why sometimes students find math frustrating, because I'm not teaching factoring. I'm expecting you to know factoring, but if you don't know it, you're going to be lost with this. So you go back and learn it, and then come back, and then this will make more sense. So my factors here will be a minus 5 times a minus 3. Now that it's in factored form, I'm allowed to cancel. I can only cancel common factors. So I have a factor of a minus 5 in the numerator, a minus 5 in the denominator. So I'm left with a plus 2 over a minus 3. In the next example, hopefully you can recognize that this is a difference of cubes. So we plug into our difference of cubes pattern. So the factor for the numerator will be t minus u times t squared plus tu plus u squared. Over the denominator, it's basically factored, but what I'm going to write it as is t minus u times t minus u times t minus u. We're not going to multiply all of this out because we do want it in factored form so that we can cancel common factors. Now I have a common factor of t minus u in the numerator. I have it in the denominator as well. So I'm going to be left with t squared plus tu plus u squared over, I can write this in factored form, or I can write it as t minus u squared. And that would be the final simplification. All right, when we take a look at this example, we notice the numerator is a difference of squares. We notice that the denominator is a trinomial with a leading coefficient of 1. So we're going to try factoring both of those, because right now I can't do any simplification. I cannot cancel terms. So I can't cancel the n squared, for example. I see a lot of students do it. They think that's the way it should be done. They remember canceling, but they don't remember the whole thing. You can only cancel common factors. So let's factor the numerator. It will be m plus n times n minus n, difference of squares. This one we can factor by finding two numbers whose product is 2, so they have to multiply to equal 2, and whose sum is -3. They have to add up to -3. So those two numbers will be -2 and -1. So I'm going to factor, it will be n minus 2m and n minus m. When we look at this and we look to see if there's any common factors that we can cancel, we don't have any right now, but notice that these are very similar. They're just opposite in sign. So what I'm going to do is factor out a -1. I can either do that in the numerator or I can do it in the denominator. I'm going to choose to do it in the denominator. So my numerator stays the same. And this factor stays the same. What I'm going to do is factor out a -1 from this factor only. And it becomes -n plus m, and I just switch the order. If I were to multiply this -1 back in, that would become -m plus n, which is the same as n minus m. So when you factor it out, it's just maybe easier to change the order so it doesn't look quite as awkward, but hopefully you understand that that is still equivalent. Now I can cancel the m minus n. So in the numerator I have m plus n. In the denominator I'm going to move that -1 factor out front. And that's more negatives than I need. So I'm going to distribute that -1 factor to each term. That term becomes negative, that term becomes positive, and it's preferable to put our positive term first, as opposed to writing -n plus 2m. This looks cleaner and neater, and that's what we want to see. So that would be the reduced fraction from this. So you're going to want to be able to factor your numerator, factor your denominator in order to reduce algebraic fractions. And just be careful when you start canceling that they're exactly the same. The factors have to be exactly the same. Know how to work with a factor of -1, because you might need to do that in your examples. And try to write it with the fewest number of negatives as possible in a final result. So go practice. You'll probably want to do some questions on equivalent fractions as well as reducing algebraic fractions. In the next videos, I'm going to talk about the operations of algebraic fractions: addition, subtraction, multiplication, and division. Okay? Practice this, and we'll see you in the next one.